In this video, I'll be showing some basic operation of queue. I'll be using array to represent queue. So I'll begin my program, and obviously I'll be using C program. And then include h. Now I will define the size of the array, which is max 100. I will declare the array globally so that each function can use it. Size would be max. I'll be dealing with the queue with two variables. One would be front and another would be rear. The front will be pointing at the first element of your queue, and the rear would be pointing at the latest element that you have inserted into the queue. And the initial value of these two variables would be -1. -1. Okay. Now first enqueue function. I'll need some variables. Let me declare them. And now need to ask the user how many data he wants to add into the queue. Now I will scan n as the number of data the user wants to input. So I've scanned n. Now I'll be using loop to take n number of data from the user as input. There you go. Now asking the user to enter the element. Done. We'll have to scan the data. Now if you are inserting the first data, you should remember that the front should be moved along with the rear. But when you are inserting the second data, the front should be remained at the first position, but the rear should be moved along with the data. So you will need a condition for the first inserted data. So it should be when I equal to 0 and front equal to -1, we will just increment front, then the value of the front would be 0, and increment rear, the value of the rear would be 0, and you will give the data into the rearth index, which would be 0th index of the array. Now moving on to the next. If the element you are inserting is not the first element of the queue, then it will be rear would be incremented, and then you will just insert the data into the rearth index. So that is it. So it's basically the enqueue function. I'll be moving on to the dqueue function. So it's by dqueue. I'll need a variable. Let's say I, and I'll need a loop. Remember, in dqueue I'll be deleting the element from the first of the. I'll be deleting the element that front is indicating, which is at the first of the 0th index of the array. So I'll need to do a left shift. So the element which is in number 180, the element in the array which is stored in the number 1 position will be moved to the 0th position, and the which is stored in 2nd position will be moved to the 1st position, and the element stored in the 3rd position would be moved to the 2nd position. So they will be moving for leftwards. So it's called left shift. So we'll be performing this from front. It would be till rear. We'll be incrementing this to this. So ith index of the array would be replaced by the value of I plus 1th index, which is left shift. That's it. And since we have deleted an element from the queue, the number of index of the array has been decreased by 1. So we'll just decrement rear, and we can then just print done. Okay, let's dequeue. Now let's continue with display function. Well, it's quite simple. You'll just make a variable, run a loop from front to rear, and then it would be I less than or equal rear, and you'll just print them %d. Simple. Now the size of the queue, right? Size. So for this we will need a variable I, and then you will need to run a loop again from front to rear, so that you can count how many elements are there in the queue. And make sure I plus plus, and this. So here the value of I would be the size of your queue. So you'll just print the value of I as size of your queue. Done. Now we'll write the main function. We'll need a choice. We'll need an infinite loop so that we can put our choices every time. Just to make it look better. Well, our first option would be to add an element into the queue, which is enqueue an element. Enqueue elements. Enqueue element. This would be our first option, and our second option would be to dequeue an element. Remember, the element you are about to dequeue would be dequeued from the front, not the rear. It will be deleted from the front. And the third option would be display the queue. Fourth option would be to view the size of the queue. Okay, and we'll have a exit option from the program. Now we need to showcase to ask the user to make a choice. And we'll have to scan in choice. Okay, done. Now we'll be using a switch case. Switch case. We'll be using a switch case. Now here case 1 would be our first option, which is enqueue. So we'll be calling the enqueue function. Enqueue function call. You printf. You can say operation successful. 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 Okay, so it's we'll just write break. Now case 2 would be dequeue. We'll just call the dequeue function and write break. In case 3 is to display the queue, so we'll be calling the display function. So now break, and there was a case 4. We'll just we'll call the size function. Break, and case 5 is to exit the program. Just exit, and default choice would be wrong choice, and here. So the program is done. Let me recheck if I see any problem. Well, looks good to me. Now let's run this. Running. Oh shit. Well, should have include. Okay, here I go. First is to enqueue an element. Let's say I want to enqueue 5 element. So the first element would be 3, 4, 5, 6, 7. Operation successful. Now I will dequeue an element, so the 3 would be dequeued if I want to dequeue. So I'll press 2 to dequeue an element. So the first element should have been dequeued from the queue. Let's see if that has happened. I'll display with 3. You can see that 4, 5, 6, 7 is here, but 3 is not here since it was dequeued. Now we will see the size of this queue with 4. So you can see size of the queue is 4. 1, 2, 3, 4. So that's the basic operation of queue, and that I was. And thank you for watching.